Welcome to this lesson video on tower cranes. We will cover 5 learning objectives in this lesson. Similar to mobile cranes, we'll learn about the types of tower cranes, their assembly process, the calculation of their safe lift capacities, and the disasters that can happen if the tower crane safety precautions are not followed. Last lesson, we learned about some cool mobile cranes like the all-terrain, rough terrain, truck-mounted, and crawler cranes. It's good to check the previous lesson on mobile cranes as there are a lot of concepts that we'll recycle and examine again when we learn about tower cranes. Tower cranes are huge temporary structures on the construction sites to help lifting many heavy loads in a very concentrated area, like a high-rise building or a tall bridge pier. A tower crane lifts and moves the load using a trolley that is operated by a cable hoisting system on the crane jib. The weight of the jib and the hoisted load is countered by the counterweight on the other side of the tower. Mast, which carries everything we just mentioned. The tower is controlled by a cabin at the point where the mast and the jib meet. All cranes have 3 main movements: hoisting the hook block over with the load up and down, trolleying the load closer and farther from the tower mast along the jib, and slowing or rotating the jib around the tower mast. Some smaller tower cranes can travel along a path close to a longitudinal construction operation. The shown diagram is for a tower crane type called top slowing because the rotation ring is located at the top of the tower mast that stays fixed and does not rotate. Some lighter tower cranes can be bottom slewing tower cranes, where the slewing ring is at the base of the tower mast. In this case, the whole crane with its mast and jib swing. The tower jib can come in 3 main configurations. The saddle jib, also known as a hammerhead, are the most common tower cranes as they provide multiple benefits. Saddle jib cranes are generally cheaper to rent, provide quicker operation, require lower power, and are easier to erect and dismantle. They also require minimal support on the constructed buildings, as a saddle tower crane can support itself for up to 100 feet height. Flat top or topless cranes started gaining popularity in early 2000s, and they comparably are lighter than the saddle jib. The luffing jib cranes provide a great solution to tight construction sites where the front jib can be lifted using a strong rear pendant and cables. You will most likely see luffing cranes in the skyline of large cities like New York, Chicago, and Seattle. As we mentioned before, the base of the tower crane can be fixed to its own foundation base, or it can travel on rails or wheels supported by longitudinal footings. Every crane has its own maximum freestanding height, where it has the structural capacity to hold itself and the lifted load without the need for any support except for its base. Sometimes there is a need for a tower crane to reach beyond its maximum freestanding heights. In such a case, the tower can reach higher elevations by bracing it to the building that is being constructed. This requires careful structural analysis and design of these braces and their connection to the building. The assembly of the tower crane is a major mobilization activity that requires considerable time and budget. Let's see this video where of the erection of a climbing tower crane. Let's step back a little and reflect on the situations where we need to use a tower crane, not a mobile crane. First, tower cranes are great for projects with very tight footprints and don't have enough space for setting up a crane and its outriggers. Second, tower cranes virtually have no limit on the lift height. If strategically placed, tower cranes don't really need to be moved, as they can come with great coverage of the site. Finally, tower cranes produce much less noise due to their AC alternating current engines. It's clear now that the location and layout of the tower crane is very critical and needs great planning and attention. The good news is that there are no many options when it comes to tower cranes. You are limited to one or two cranes that are available from the contractor fleet or from an renting equipment company. As such, the location is the main decision that needs to be made. This layout decision requires the following steps. First, the contractor identifies the heaviest loads that will be lifted by the crane, be it a concrete bucket, structural element, structural steel elements, or heavy mechanical, electrical, or plumbing equipment. As we did with mobile cranes, we need to include the weight of the slings and any platforms or containers to lift the load. A working margin factor is used to increase the lift load to account for non-ideal loading cases like wind and dynamic loading. Based on this maximum load we picked from the crane manufacturer manuals, the shortest crane jib that can support this maximum load. Here is another format to show the crane manufacturers of how the crane manufacturers publish the crane capacity chart. Every one of these curves represents the load capacity for a jib length. You can see that all jibs have the same capacity for short load radius distances, as they are subject to the same hoisting system failure, not the jib itself. After that region, the different jibs will have different capacity value for the same load radius, where the shorter jib length with less dead load provides higher capacity. For example, all jib lengths can carry a load of 12,000 pound, but the 98 feet jib is the shortest safe jib, and because of its lower weight, lower self weight, it can carry the left load to further distance. Here's another way tower crane capacity information is published. For this crane, maximum capacity for any jib is 27,000 pound, which is the same hoisting system failure that can happen for all the jibs. The shortest jib always fails with this maximum capacity due to the shortest radius and low moment loads. For the longest jib, number L7, it can sustain this maximum capacity to only 88 feet hook reach. Afterwards, its capacity fails due to the bending moment loads created from its own heavy weight. The crane capacity tables or sheets differentiate between two trolley system types: the two-part line trolley hoisting system and four-part line system. The four-part line system utilizes an extra pulley to provide four cross sections of cables to carry the load instead of two. These two tables are for the same tower crane, but for the trolley system, for the two trolley system types. The charts list different values, but you can see that the values in the four-part line crane provide double the capacities when the crane is equipped with two-part line. This is because the four-part line hoisting system has double the cable cross-section used to lift the load. The third step in determining the tower crane location is to identify the crane loading and unloading points. This is done as part of the site logistics planning, not just focused on the tower crane operations. The site logistics plan determines the loading point or points. What about the unloading point? To provide more flexibility in the future crane operations, we can assume that every point in the whole building will be a loading point. But we only need to examine the extreme outer points as the extreme cases of unloading. We will examine every pair of loading and unloading points and pin down the crane location that can serve both points. Let's start with the loading point and the first unloading point. We draw a circle around each of the considered points, and the radius equals the maximum crane hook reach that we identified from the crane capacity chart. For these 2 points, the crane can be placed in the overlap zone between these 2 reach circles and the side footprints. Any point in this hatched zone is a feasible location to place the tower crane for this loading and unloading pair of points. We will repeat this same process for a different pair of points. Draw the reach circle around the second unloading point, and we see our feasible crane base spots are getting less, considering the third unloading point, and we are ending with less feasible zone for the crane, and finally the last unloading point, and we end up with a small feasible zone to set up the tower crane. Of course, it's better to consider the face line of the building edge to place the tower in case it needs to be braced to the building. This other example shows the case where there was not single feasible crane point that can cover the whole project. In this case, we will need 2 tower cranes, each serving a building in this project. Some complex and large projects require multiple tower cranes to be able to cover the entire building footprint. There can be some redundant overlaps between the tower cranes where a single point can be covered and served by more than 1 tower crane. Let's work on this exercise to check if the provided tower crane can lift the heaviest load in this project. The crane already comes equipped with a L7 jib and a 4-part hoist line. The maximum reach is 90 feet and the heaviest load is 26,000 pounds. The load will require a spreader bar and a sling that come with their own additional weights. We focus on the 4-part line capacity table and locate locate the cell that corresponds to the equipped crane jib and the hook reach. This means that the gross crane capacity will be 26,100 pounds. Now we need to compare the gross load to the gross capacity. We add all the weights of the lift and its accessories to be 27,700 pounds. Then we add a working safety margin of 5%, which results in a gross load of around 29,000 pounds. This is much more than the crane capacity, and it's recommended to either change the crane configuration or the site logistics plan. The construction speed in high-rise building construction is very dependent on the duty cycle of the crane, which is the time the crane takes to lift a load from the pickup point to the drop-off point and return for the next load. This duty cycle includes repeating the main crane movements shown here: hoisting, trolleying, and slewing. Also, the time includes the tasks of attaching and deattaching the load from the crane hook. The crane duty cycle is calculated based on the distances between the pickup and drop-off points and the speeds of the mechanical movement of the crane. Here are some suggested speeds for the slewing and in round per minute, and trolleying in feet per minute. The hoisting speed is dependent on the hoisting system type, if it is a 2-part or 4-part line system. Also, it depends on the horsepower of the crane AC engine. This table shows the speeds for a crane that can be equipped with 2 engine sizes, and 2 hoisting system types. We can see that the stronger the engine, that the stronger engine provides higher hoisting speed for the same hoisting system. For the same engine horsepower, the 4-part line hoisting is 2 times slower than the 2-part line hoisting. It takes double the time for the hoist line to go through the additional pulley that exists in the 4-part hoisting. The last part we will cover here is the safety of tower crane, which is not seriously considered. If not seriously considered, can result in disasters that are not limited to only the construction site. This is just an example of statistics that show the number of tower crane accidents and their fatalities worldwide. When a tower crane fails, it threatens the properties and human life around the site, as we can see in these photos. Almost a quarter of the accidents happen from strong winds and storms that hit the construction sites with the tower cranes that are not well braced or well sized for the local climate. More than a quarter of the accidents happen during the very vulnerable time of assembling the crane or during its climbing process. As we have seen in the animation video, the tower crane is in its weakest time when it is being assembled or raised. That is the end of this lesson. I hope you appreciate the amount of effort and time that goes into planning and managing crane operations on the construction site. Thanks for watching and take care.